Okay, so let's take a look at some examples together. So here it's asking us to use property 1 to solve the following, A, B, C, and D. So they don't necessarily have to tell us to use property 1, we should see it. And the other thing is, notice that here we have X's, A's, Y's, and Z's. Don't let that disturb you as well. They can use any letter they want, as long as the bases are the same. That's what we care about. Okay, so if you look at the first one, we have x to the 6 times x to the 2. So since we have a multiplication, the bases are the same, what do? Property 1 says to add the exponents. So we have x to the 6 plus 2, which is just x to the 8. And that's your answer. So if you want to give the other ones a try on your own, make sure you're able to follow. And make sure your answers are the same as mine as well. So here we have a to the 3 times a to the negative 2. So since the bases are the same, we just add the exponent. A 3 plus negative 2. So 3 plus negative 2 is the same as 3 minus 2. So it's 3 minus 2 is 1. A to the 1, which we could also write as just a. So whenever the exponent is 1, you could just not write it. We know there's an exponent 1 there. But if you're still not comfortable with it, I think in the beginning you should still write down the exponent because it's not wrong. Okay, that's the answer for B. Now C, y to the negative 8 times y to the 13. The bases are the same, they're both y's. So again, we add the exponent, negative 8 plus 13. And that gives us y to the 5. That's finished. And lastly, we have 3 numbers now. So we have z to the negative 8 times z to the negative 13 times z to the 24. So again, don't let that bother you. They're all multiplying, so we just add all the exponents. So we have z to the negative 8 plus, let's put in brackets, negative 13 plus 24. Let's do that. This gives us negative 8 minus 13, negative 21 plus 24, z to the 3. And that's your final answer. Okay, keep up the great work. I'll see you in the next example. Okay, so now in this example here, we're asked to use property 2 to solve the following. X to the 6 divided by x to the 2 now. So since we have a division and the bases are the same, we subtract the exponents. X to the 6 minus 2 equals x to the 4. That's your answer. Here we have a to the 3 divided by a to the negative 2. So that gives us a to the 3 minus negative 2. So be very careful with the negatives. 2 negatives turn into a positive. So 3 minus negative 2 is the same as saying a to the 3 plus 2. So the answer here is a to the 5 because 2 negatives make a positive. So we get a to the 5. Same thing here. We have y to the negative 8 divided by y to the negative 13. That gives us negative 8 minus negative 13, which is the same thing as y to the negative 8 plus 13, which gives us y to the 5 again. And then lastly, D, we have a mixture. We have a multiplication on the numerator and we have a division. So let's start off with the multiplication on top. Z to the negative 8 times z to the 24. So that gives us z to the negative 8. Since we're multiplying the numerators, we add the exponents. Over z to the negative 13. Negative 8 plus 24, we get z to the 16 over z to the negative 13. And now here we're dividing, so we subtract the exponents. So z to the 16 minus negative 13. Again, be careful with this double negative. Students often fall for these tricks. It turns into addition, so 16 plus 13. So the answer is z to the 29. And that's done. Great job. I'll see you in the next example. Okay, so far the previous examples that we've been working on have been warm-up questions. Now these ones are starting to get a bit more involved and we're combining different properties that we're using. So example 3, we use properties 3, 4, and 5 to solve the following. So we have A, B, C. So let's start off with A. Again, I think it's a good idea to write down the exponents. Remember that everyone has their own exponent. So it's really 2 to the 1, a to the 1, and b to the exponent 3. And since we have all this in bracket to the exponent 2, you have to distribute the 2 to everyone's exponent. So this gives us 2 to the exponent 2 times a to the exponent 2 times b to the exponent 6. Okay, And if you could simplify, simplify. So here 2 squared, we know how to do that. 2 squared on the calculator, we get 4. A squared, you leave it, and B 6. And this is the final answer. Don't leave your answer as 2 squared. If you could solve it on the calculator, do so. Now let's look at B together. B, we do the same game. Write down everyone's exponent. I think this is a good way to start. So 4 exponent 1, y exponent 3, z exponent 1, 3 exponent 1, x exponent 2. And we multiply the 2 on the outside to everyone's exponent, not just the numerator, the denominator as well. So everyone gets invited to the party, don't leave anyone out. So we have 4 exponent 2, y exponent 6, 3 times 2 is 6, 1 times 2 is 2, over 3 to exponent 1 times 2 is 3 squared, x squared times 2 is x4. Okay, so now 4 squared, we could do this, it's 16, y6, z2, over 3 squared is 9, over x4. And this is our final answer. Okay. Now last, let's look at C. C, this looks a bit intimidating because instead of x's and y's, we have just numbers. So you could actually attempt to do this on the calculator, but it's actually easier to use your properties as opposed to plugging this into the calculator. So using our properties, what I first noticed is the numerator. We have 5 to the 2 times 5 to the 3. So I would like to go and combine those numbers. Use property 1 where we have to multiply. If you were thinking of distributing the 3 here to everyone's exponent, that works as well. So it doesn't matter which way you start, it's really up to you, as long as you get the same final answer as me. So I'm going to start with the multiplication inside here. 5 to the 2 times 5 to the 3, the bases are the same. So we get 5 to the 2 plus 3 is 5. So 5 exponent 5. Divided by, let's do the 7s at the same time. So you're multiplying the same base. 7 to the exponent 4 times 7 to the exponent 2. The base is the same, it's a 7. And then you add the exponents because they're multiplying, and you get 6. All this to the exponent 3. And now at this stage, I'm going to distribute the 3 to the exponents. This over here, and the 3 over here to the 6. So now we're multiplying the exponents. So you get 5 to the exponent 5 times 3 is 15. Over 7 to the exponent 6 times 3, 7 to the exponent 18. And this is our final answer. There's nothing left to do. Okay. Good job, guys. Keep practicing, and I'll see you in the next example. Okay, so let's take a look at example 4. Here it's asking us to use lots of exponents to solve the following expressions. And it says also to express your answer using positive exponents. So you always have to simplify. Do not leave your answer with negative exponents. Math teachers don't like that. Okay, so let's look at A. This looks very intimidating. But again, try the problem on your own. See if you get the same answer as me. Looking at A, there's a lot going on here. We have really big numbers, but the thing that I noticed is it's all in brackets to the exponent 0. So I'm not even going to look in the inside. I know the answer here is just 1. We're done. Let's look at B. So B is a bit more involved. It requires a bit more work. So what I would probably start with is the distribution of the exponent on the outside. That's just me personally. That's where I like to start. If you want, you could add the exponents. 7 has its own exponent. 2 has its own exponent. So put 1s if you want. And then you distribute the exponent on the outside to everyone's exponent. Something like that. So what we get is 7 to the exponent -2 times a to the exponent 6. So remember, we're multiplying. -3 times -2 is +6. B to the exponent -4 times -2 is +8. 2 negatives make it positive. Divided by 2 to the exponent -2. -1 times -2, so a exponent +2. And b to the 0 times -2, it's b to the 0 times -2 is just 0. Okay. Now let's go ahead and simplify. The next thing I would probably do is I'm noticing the b to the 0. We know this is just 1. Anything to the exponent 0 is 1, so this is, you don't even have to write it. So we have 7 to the -2, a to the 6, b to the 8, over 2 to the -2, a to the 2. The next thing I usually deal with is the same variables. So I'll leave the numbers for now. But the thing that's bothering me is the a's. We have two a's here, so let's simplify that. The a's are dividing each other. We have a to the 6 on top, a to the 2 on the bottom. Since there's a division with the a's, we subtract. So 6 minus 2, we get a to the 4. And remember, when we subtract, your answer always goes on the numerator. So we get 7 to the negative 2, 2 to the 2, 2 to the negative 2. And a to the 6 divided by a to the 2 is a to the 4 on top, and b to the 8. So remember, we cannot leave negative exponents. That's one of the requirements. So the negative exponent, the 7 has a negative 2, so the 7's upstairs and it's angry. What do? Bring him downstairs and he's happy. So the 7 drops down on the bottom, 7 to the 2, and the 2 has exponent negative 2 on the bottom, so he's downstairs and he's angry. What do? Bring him upstairs. So the 2 goes upstairs and his exponent now is positive. A to the 4, b to the 8. So again, this isn't good enough if you stop here. If you could simplify further, always simplify as much as possible. So 2 to the 2 is really just 4. So make sure you do that. You don't stop here, that's too early. A4, B8, there's nothing left to do there. Divided by 7 squared is 49. So this is your final answer. Okay, so you can see that the problems are a lot more involved. But let's keep practicing, because this is a typical part B question. Usually multiple choice or part B question on exams. Okay, so let's look at another example together. On this example, it's the same thing. Use lots of exponents to simplify this expression, and always express your answer using positive exponents only, no negative exponents. So let's go ahead and start this together. Let's start off by writing the exponents of the 10, the 1, 5 to the 1, and z here to the 1. Okay, just to remind ourselves, and let's go ahead and distribute the exponent on the outside. So the negative 1 hits everyone's exponent. Okay, and on the bottom as well. You're multiplying the exponents, not the actual coefficients in front. So what we get is 10 to the negative 1 times x to the negative 4 times y to the 5 times z to the negative 6. So essentially the exponents just switch signs because you're multiplying by negative 1. And same thing on the bottom. So 5 to the negative 1, x to the 2, y to the negative 2, z to the negative 1. So the next thing that I like to do is I like to group my the variables that are the same. So I kind of ignore the numbers for now. We have 10 to the negative 1 on top and 5 to the negative 1 on the bottom. That's kind of bothering me because we have negative exponents, so there's work to do. But let's start off by combining our x's, y's, and z's. So x, we have x to the negative 4 and x to the 2 on the bottom. Since they're dividing each other, we subtract. So x to the negative 4 minus 2, that gives us x to the negative 6. Minus 4 minus 2 is negative 6. Then we have y to the 5 minus y to the negative 2. So just remember, y to the 5 minus negative 2, if you have to write it down on the side and simplify it. 2 negatives turn into a positive, so it's the same thing as 5 plus 2, which is y to the 7. And remember, whenever you write your answers when you're dividing, it's always going to be written on the numerator. Okay, and then z to the negative 6 divided by z to the negative 1, so we subtract z to the negative 6 minus negative 1. So 2 negatives turn into a positive. That's the same as negative 6 plus 1, which gives us z to the negative 5. Okay, z to the negative 5. So this is how I started off. The next thing I do is deal with the negative exponents now. So let's erase this. This is just work we did on the side. So negative exponents. The 10 is on top. Negative exponent, it's angry, so we drop him down. So 10 to the 1. 5's on the bottom. He's angry with the negative exponent. What do? We bring him up. Switch the sign. X to the negative 6 on the top. He's upstairs. Let's bring him down, and now he's happy. Y to the 7, the exponent's already positive, so he's happy upstairs. We leave him upstairs. And then z to the negative 5, he's upstairs, he's angry. Let's drop him down. Z to the 5. Okay. So this is good. If you stop here again, it's premature. Be careful with the coefficient. Yeah, with your coefficients in front. So you have 5 and 10. You can reduce these numbers. 5 divided by 10 is really just 1 over 2. So we could write y to the 7. The 2's on the bottom. X to the 6. Z to the 5. And this is the final answer. Okay. Great work. Let's keep it up. Let's look at the next example. Okay, so in this example here, we have 4x to the 4, y to the 5, all that times 7 to the negative 3 times y to the negative 5. Okay, so as always pause the video, try to attempt them yourself, and then compare your answer with my final answer. Okay, so the first thing here I notice is 4 is a number, 7 to the negative 3 is a number. So we could kind of just leave the numbers in the front. So 4 to the 1 times 7 to the negative 3. There's an x over here, so let's ignore the x's because there's no other x's. We'll just put them over there. Then we have y to the 5 times y to the negative 5. So here, since the y's are the same, you could add their exponents because they're multiplying. And notice that I brought the 7 to the negative 3 in the front. Why am I allowed to do that? Well, when you multiply, does it matter the order in which you multiply? Like 2 times 3 is 6. What if I do 3 times 2? If I reverse the order of the multiplication, my answer stays the same. So you're allowed to do that. Whenever you're multiplying, when everything's multiplying each other, it doesn't matter the order in which you multiply. The answers remain the same. Okay, so that's why I'm allowed to take the 7 to the negative 3 and move him to the front. And now since we're multiplying the y's, we add the exponent. So y to the 5 plus negative 5, you're left with 0. Okay, and now we get 4 to the 1 times 7 to the negative 3 times x to the 4, and y to the 0, we know from our property number 7, it's just 1, so I'm not going to write it because you're multiplying by 1. Multiplying anything by 1, it doesn't change the number. Next, let's deal with the negative exponent. So think of this as all this over 1 because every number is over 1, so you can think of all this upstairs, so we have to bring the 7 downstairs. So we're left with 4 x to the 4, and the 7 to the 3 drops on the bottom. Okay, and let's go one step further. 7 to the 3, we could do this on the calculator. That's 7 times 7 times 7, which gives us 343. And this is our final answer. Okay, let's move on to the next example. Okay, so in this example here, we have 4r to the 4 times t to the 5, all that to the exponent 3 times 3r to the 4 times t, all that to the exponent negative 2. So the first thing I would do is probably get rid of the exponents. Let's go ahead and do that. So let's start off by writing all the numbers that have exponent 1 and then distributing the 3 on this side and distributing the negative 2 on this side to everyone's exponent. So this gives us 4 to the exponent 3 times r to the exponent 12, because 4 times 3 is 12, and then times t to the 5 times 3 is 15. So the left bracket is done. Let's move on to the right bracket. So we have 3 to the 1. We're multiplying the negative 2 times the exponent of the 3, so it's 3 to the exponent negative 2. R to the exponent negative 8. 4 times negative 2 is negative 8. And then t, the exponent is 1. 1 times negative 2 is t to the negative 2. Okay. So again, I put my numbers in the front. So we get 4 to the 3 times 3 to the negative 2 is a number, so I'm just going to put it here for now. And now I look at my same variables. So r to the 12 and r to the negative 8. These guys are multiplying each other, same base, so we add the exponents. 12 plus negative 8 is the same as r to the 4. 12 plus negative 8 is the same as 12 minus 8, which is 4. And then we have our t's. So we have t to the 15 times t to the negative 2. We're multiplying, so we add the exponent. 15 plus negative 2 is the same as 15 minus 2. So we get t to the 13. Okay. So again, think of this as a number over 1. Every number is over 1. So the 4 stays upstairs. 4 to the 3 times r to the 4 times t to the 13. And since the 3 has a negative exponent, it's upstairs, it's math, we bring them down. So we get 3 to the positive 2. Okay. And lastly, we simplify the numbers. 4 to the 3 is 4 times 4. 16 times 4 is 64. Times r to the 4 times t to the 13 over 3 squared, which is 9. Can we simplify? I think that's the furthest we could go, so this is our final answer. Okay, great work. Let's look at another example. So in this example here, we have x to the 3 divided by y to the negative 3 times z to the 4. All that times y to the 5 times z divided by x to the 5 times y times z to the negative 5. So let's just quickly put the exponents. Z has an exponent 1, y has an exponent 1 there, just to remind ourselves. And what I like to do here is I like to multiply everyone on the numerator and then multiply everyone on the denominator. So this is the way I would go about doing this. There's different methods, so you don't have to exactly do it the same way that I'm doing it, but as long as you get the same final answer as me, then your method is correct. So on the numerator we have x cubed y5 z, so I like to put it on one line, x cubed y5 and then z. You could put z to the 1. And I also like to put in alphabetical order. Again, you don't have to do that, but depending on your teacher, do it your teacher's way. But on the bottom we have an x to the 5. There's nothing to do there. And then notice that there's two y's. We have y to the negative 3 and y to the 1. Since we're multiplying on the denominator, you add the exponent. So negative 3 plus 1, we get y to the negative 2. And then we have z to the 4 and z to the negative 5. So again, we're on the bottom, so we're multiplying these two numbers. So we get z to the, add the exponents, 4 plus negative 5 is z to the negative 1. Okay. And now what I do is I do the division. So I do my x's first. We have x to the 3 divided by x to the 5. We subtract the exponents, so we get x to the negative 2. 3 minus 5 is negative 2. Think of it again over 1. Every number is over 1. Y to the 5 over y to the negative 2. You subtract the exponents. 5 minus negative 2. Be careful here. If you're thinking 3, that's wrong. The answer is 7. Double check on your calculator. Be careful with the negatives. Those are the most common mistakes in these types of problems. Lastly, we have 1 minus negative 1, so it gives us again z to the 2. They don't cancel each other. And then lastly, we have to get rid of the negative exponents. So the y is exponent 7, it's happy upstairs. Z exponent 2, it's happy upstairs. The only one that's unhappy is the x, so we have to drop them down. So leave the y, leave the z, and the x is dropped down, x to the 2. And that's your final answer. Okay. You guys keep up the great work, and let's look at the next example together. So in this example here, we have 4a to the 3b to the negative 2, all that divided by 12a to the negative 2b to the negative 5, multiplied by 5a to the 5b to the 3, all that divided by 2a to the 4b to the negative 9. Okay, so we have to simplify this. Again, what I like to start off with is I focus on the numerator, and then I focus on the denominator. So I like to put it over one fraction, one big fraction. So let's put the numbers on the numerator together. 4 and 5 don't have exponents, so you can multiply them. 4 times 5 is 20. Let's put that in front. And then we have a to the 3 on top and a to the 5. If we combine our a's, they're multiplying on the top. So 3 plus 5 is a to the 8. And then same for the b's. B to the negative 2 times b to the 3. Add the exponents, you get b to the 1. And we do the same on the denominator. So 12 times 2, we get 24. A to the negative 2 times a to the 4 is a to the 2. You add them. And then b to the negative 5, b to the negative 9, we're adding them again, so we get b to the negative 14. Okay. Next step, we divide the numbers. I'll leave the 20 and the 24 for now. But here the a's, they're dividing, so we have to subtract the exponent. We're left with a to the 6. 8 minus 2 is 6. And same for the b's. It's 1 minus negative 14, so we get b to the 15. So be careful again with negatives. 1 minus negative 14 is the same as 1 plus 14. So you get b to the 15. Again, this isn't good enough. You have to simplify. 20 over 24. These are two even numbers, so we could divide them. So we get, divide them by 2. We could divide them by 4. Yeah, we could divide by 4. So we get 5a 6b 15 over 6. Yeah, because we have to reduce the fraction. 20 over 24 is the same as 5 over 6. And this is our final answer. Great job. I'll see you in the next example. Okay, so in this example here, we have 6 to the 1, x to the negative 3, y to the 2, all that divided by 3 to the 1, y to the 3, x to the negative 3, all that in brackets to the exponent 2, multiplied by 3 to the 1 times x to the negative 2 times y to the 5, all that divided by 9 to the 1, x to the 5, y to the negative 8, all that in brackets to the exponent negative 3. So the first thing I did is I multiplied the exponent to everyone else's exponent. Okay, and same for the negative 3 here. I multiply to everyone's exponent. So that gave me 6 to the 1 times 2 is 2, x to negative 3 times 2 is negative 6, y 2 times 2 is 4, 1 times 2 is 2, 3 to the 2. For the y, it's 3 times 2 is 6, and for the x, it's negative 3 times 2, it's negative 6. And same thing on the other bracket. So we multiply everyone's exponent by negative 3, so we get 3 to the negative 3, x to the 6, y to the negative 15, 9 to the negative 3, x to 5 times negative 3 is negative 15, and y to the negative 8 times negative 3 is positive 24. Okay, so next what I would do is the same as the last example. I just multiply everyone on top. So let's ignore the numbers for now. We'll put them in the front. So 6 to the 2 is going to stay. 3 to the negative 3 stays over here. And now let's deal with the x's. So we have x to the negative 6 and x to the 6 on top. We're multiplying because they're both on the numerator. Negative 6 plus 6, so we add the exponents, which gives us x to the 0. And at this point here, we know that x to the 0 is 1. So I'm just not going to write it because multiplying by 1 doesn't change the number. Next we have the y's, y to the 4 times y to the negative 15. We add the exponents because we're multiplying. So 4 plus negative 15, we get y to the negative 11. Okay, so the top is done. Let's do the bottom. Again, let's ignore the numbers. Let's put them to the front. So we have 3 to the 2 times 9 to the negative 3. Let's put them in the front. And now let's deal with the x's. So we have x to the negative 6 and x to the negative 15. Since we're multiplying on the denominator, we add the exponents. So negative 6 plus negative 15, that gives us x to the negative 21. And let's do the same for the y's. We have y to the 6 and y to the 24. Add the exponents. 6 plus 24 is 30. So we get y to the 30. Okay. Now let's deal with the x's. The x's are done. The next thing I'll do is deal with the y's. Since they're dividing at this point, we subtract the exponents. So this gives us on the top 6 to the 2 times 3 to the negative 3, 3 to the 2 times 9 to the negative 3, and we get negative 11 minus 30 is y to the negative 41 on top, and x to the negative 21 on the bottom. Okay. Now let's deal with the exponents. Everything that has a positive exponent stays. Whatever has a negative exponent flips. So the 6 to the 2 stays on top. 3 to the negative 3 is going to drop down. And now that we dropped the 3 to the negative 3, it's going to become positive 3. We have 3 to the 2 on the bottom. That stays. 9 to the negative 3 on the bottom jumps up. Y to the negative 41 is on top, so we bring him down and the exponent switches to a positive 1. And on top, the x becomes 21. So the x is negative on the bottom, we brought him up, and now he's positive. Okay. And now we just have to simplify the numbers here. These ones here are very large. Let's use a calculator. So we have 6 squared times 9 to the 3. And this gives us 108 on top, x to the 21, all that over y to the 41. Okay, and that's the final answer. So great job. I hope this helps. If you have any questions or comments, please don't be shy, leave them. And if you have specific questions you would like me to solve, or certain types of questions you would like me to solve, don't be shy to write in the comments.